Okay, today we learned about recursive and explicit formulas. So we're going to use a recursive formula to list terms in a sequence, and then we're going to practice writing recursive and explicit formulas for arithmetic and geometric sequences. An explicit formula, this allows you to find any term of a sequence by using a formula written in terms of n. So an example in an explicit formula would look like this: a sub n equals 2n. There are a couple of ways that we can change this. We could say y equals 2x, and then you'll recognize that that's linear. Or we could say f of x equals 2x, or we could even say f of n equals 2n. So there are a couple different ways that you might see this explicit formula written. What this says is that if we were trying to find the fifth term, a sub 5, we would take 2 times 5. N is 5. So a sub 5 would be 10, and the fifth term would be 10. A recursive formula allows you to find the nth term of a sequence by performing operations to one or more of the preceding terms. Okay, so it'll start out by telling you what a sub 1 is 2. Then to find a sub 2, you have to take this 2, the term before it, and add 2. So that's why this says 2 plus 2. It's replacing a sub 1 with 2. And then to find a sub 3, we have to take this 4, take the term before it, and add 2. Then to find a sub 4, we have to take the term before it, that's where that 6 comes from, and add 2. And you would continue on. If you had to find a sub 5, we would take the answer of the previous term and add 2 to get to 10. So the recursive formula for this sequence, will first tell you what the first term is. Then it will give you a recursive formula that says that it's taking the term before the last, or before this term, and you add 2 to each time. And it's also telling you that n has to be greater than 2, meaning that the term that we will start with has to be greater than 1. It can be 2, it can be 3, it can be 4, but we're going to say it has to be greater than 1. Or here it says greater than or equal to 2. So this is what a recursive formula looks like. It's asking us to find the first 5 terms. We do know what the first term is. It's -2. To find the second term, you're going to take -3 times, this says times the previous term. The previous term was this -2. And then add 4. So when we do this, we get -3 times -2 is 6, plus 4 is 10. We're going to continue using this recursive formula. So this says that we take -3 times the previous term, which was 10, and then add 4. -3 times 10 is -30 plus 4 is -26. So to find a sub 4, we take the previous term, multiply it by 3, and add 4. So -3 times -26 is 78 plus 4 is 82. And to find the last term, we take -3 times the previous term, 82, and add 4. -3 times 82 is -2. 46 plus 4 gives us -242. From there, we're just going to list out our first 5 terms. -2 is the first one, followed by 10, -26, 82, and then our last one was -242. Same idea here. Our first term is 7. To find the second term, it says that you're going to take whatever the previous term was. In our case, it was 7, and add 12. So that gives us 19. A sub 3, we're going to take that previous term, 19, and add 12. So we get 31. A sub 4, you take the previous term, 31, and add 12 to get 43. And one more time, a sub 5, we take the previous term, 43, and add 12, which gives us 55. So we would write out these terms: 7, 19, 31, 43, then 55. We can see that this is linear. It's also arithmetic. We're adding 12 to each of these values to get to the next term, so we would consider this an arithmetic sequence. So I'm going to give you some steps to writing a recursive formula. Your first step is to determine if the sequence is arithmetic or geometric by finding out if you have a common difference or a common ratio. After you have determined that, you're going to write the recursive formula using, if it's arithmetic, we use this formula, a sub n equals a sub n minus 1 plus d. That's your common difference. If it's geometric, you're going to take a sub n equals r, your common ratio, times the previous term, a to the n minus 1. Then you're going to state the first term and the domain for n. So you're going to say a sub 1 equals some number, say 7. That was what it was in our last one. And then our domain will always be n is greater than or equal to 2. We're going to be looking for our terms greater than the first term. Okay, the last part, you're going to also have to write an explicit formula. Now this is what we learned in 5.4. This is your formula for an arithmetic sequence. And then we learned the geometric sequence in 5.5, so hopefully you remember seeing those formulas. Okay, so on example 2 it says write the explicit and recursive. We can start with the explicit first. It really doesn't matter which one you do first. To find the explicit, you have to identify a sub 1. In this case, it's our first term, 17. We're going to determine here if it's arithmetic or geometric. It looks like each time it's subtracting 4, so we're going to say it's an arithmetic sequence. And that helps us because then we know we have to find d. d in this case is subtracting 4 each time, so it's minus 4. For an explicit, we take that formula a sub n equals a sub 1, so 17 in this case, plus n minus 1 times d. Then once we have this, we have to do a little bit of work. You're going to start by distributing that negative 4 to both terms. So that becomes minus 4n plus 4. And then your last step is to combine like terms, the 17 and the 4. And I'm actually going to put the negative 4n first, plus 21. If you notice, we knew that this was arithmetic, and so because it's an arithmetic, it's linear, and because it's linear, we could always rewrite this as y equals negative 4x plus 21, and then this looks like a form you have seen before. But right now we're focusing on this form. I will accept either. Okay, so the recursive actually has a little bit less work. The recursive says we have to identify our first term, and in this case our first term is 17. Then we're going to say a sub n is equal to a to the n minus 1, and then you add d. In this case we're going to subtract 4, and this will work as long as n is greater than or equal to 2. And that's all you do for the recursive formula. We're going to continue. As you look at this, first determine if it's arithmetic or geometric. You can probably tell that it's geometric. And that will help you identify some things that you need in both equations or formulas. Your a sub 1 is 6, and your r, it looks like it's multiplying by 4. So your common ratio is 4. So to do the explicit formula, a sub n is equal to a sub 1, 6, times r to the n minus 1. And there isn't anything else you can do with this formula. We cannot multiply those two terms because we have an exponent, so we just leave it as that. For the recursive, we first start by saying what your a sub 1 is. Your a sub 1 was 6, and then we go to our formula. A sub n is equal to r times the previous term, and this is as long as n is greater than or equal to 2, so we're going to start at our second term after we already know our first term. On example 3, we're going to kind of do vice versa type things. It says for each recursive formula, write the explicit. For each explicit, write the recursive. So what you want to identify first is which one do we have? This one here is an explicit. And what you want to do in all of these is actually find out what your sequence is. So to find our sequence, we're going to find our first term. Our first term was when n is 1. So we take 6 times 1 is 6 plus 3 is 9. Our second term is when n is 2. So 6 times 2 is 12 plus 3 is 15. Our third term is 6 times 3. So that's 18 plus 3 is 21. And we could continue, but I think we have enough terms to look at this to write our recursive. So what you want to notice, first of all, is it arithmetic or geometric? Because it's going up slowly, we can say it is arithmetic. And it tells us, because it's arithmetic, that we have a common difference, and the common difference here is 6. So to write the recursive, says our first term was 9. Our nth term, we have to take our previous term and then add our common difference, which was 6 each time to get to the next term. As long as n is greater than or equal to 2. We have to start at our second term once we use that formula. Okay, on B, we can see that this is recursive. Once you know it's recursive, we're going to go ahead, and you don't necessarily have to do this, but we're going to do it for practice and find our terms. Our a sub 1 is 120. Our a sub 2, we have to take 0.8 times our previous term, 120. This is 96. To find our third term, we take 0.8 times our previous term, 96, which is 76.8, and we could continue doing this, but I do have some terms in my sequence that I'm going to look at. When you're looking at this sequence, we can determine that it is geometric. And once you know that it's geometric, you have to find r. We find r by taking the ratio of successive terms, so 96 divided by 120, and this reduces to 0.8, which you probably could have already picked that out. Once we know that, we can go to our explicit formula. Our explicit formula, I'll do this in a different color, starts out by saying a sub n is equal to a sub 1. Our first term was 120 times r, in our case it was 0.8 or 0.8 to the n minus 1. And that's all that's required for that explicit formula. Good luck. I know these are new. It's going to be a little bit work. We're going to practice more of this on part 2 of 5-6. So good luck. Do your best.